Hi, and welcome to Chapter 6. In Chapter 6, we're going to cover looping. Looping, or the concept of iteration, doing things multiple times. Let's get started. You probably have already understood the concept of looping in a general sense. If something occurs, if something is true, if something, then do it. Do something until it isn't true. So we have three different types of loops in Java that we're going to be using: a while loop, a for loop, and a DoWhile loop. All three of them have the same basic concept. We're going to do something a certain number of times. It may be an exact number of times, which we usually use a for loop for. And then our while loop and our DoWhile loop are very similar, and we're going to get into both of those, and then of course the difference between them. In a flowchart, you're going to see it's simply the basic concept of if something is true, then go do the stuff inside the loop, go back up to the top. If something is still true, do the thing in the loop. Otherwise, keep going and just don't worry about the loop. So let's look at these a little bit closer. In our basic while loop, we have two different styles that we can use. One is called a definite while loop and one is an indefinite. Definite meaning that it will run an exact defined number of times. So definite. So I can say this loop will run 5 times or 6 times or 12 times, whatever it happens to be. An indefinite loop runs an undetermined number of times depending on what the user's input is. We sometimes call these event controlled because the user has the option of having the loop run again. This is where you're playing a game or you're doing something, and at the bottom you say, do you want to play again? The user can say yes, and then we'll go to the top of the loop and start over. Or they can say no, we'll break out of the loop and go to the bottom. With our definite loops, we are going to run an exact amount of time. So if I say I equals 1, every time I run through my loop, I'm going to increment it by 1, and then I want to break my loop when I equals 10. That doesn't mean that you always know exactly what it would be because it's going to be controlled by the code to figure out how many times it works. Funny thing about this, remember I used the word definite and indefinite. There is also the concept of an infinite loop, which is not an indefinite loop. It's an infinite loop. It means it will never stop. It goes on forever and ever and ever. That's a definite amount of times. It's just that the number of times is infinity. So an infinite loop is a definite loop because it goes on for a defined number of times. By the way, if you find yourself in an infinite loop, Control-C will break you out of it. So it'll run the code over and over and over again until it either crashes your machine or you hit Control-C to break it. Remember, the thing that can usually cause an infinite loop is not changing what we call the control variable, the thing that's figuring out whether or not we're going to do it again and again and again. If my x is greater than 5, do it again. Well, if I never increment my x, it will never be greater than 5. So you always have to change your control variable. In an indefinite loop, we run an indefinite number of times depending on the input. And we use what we call a sentinel to be able to allow the user to break themselves out of the loop. It's the value that we're checking. In the example here over on the right, it's the word response. So the variable response is going to hold in what is the user going to return from the next int. Do you want to continue? Do you want to see the next year? Enter 1 for yes. As long as they keep entering 1, it will keep looping. If they enter anything other than 1, it will break out. So we call that a sentinel. It's the guy who's standing there figuring out whether to let you out of the loop or not. So you can imagine a little soldier standing on a parapet. Sentinel. He's standing there figuring out whether or not to let the loop keep going. One of the things that we like to use while loops for is what we call validating data, making sure that the user put in the right information. We're going to show you in some code here in a second how to use a while loop to make sure that the user puts in values that you like, values that you're expecting. If I can only allow my user to enter a 1 and a 2 and they enter something other than a 1 and a 2, I want to stop them and say, hey, I asked for a 1 and a 2. Please give me a 1 and a 2. And then it will only let you out of the while loop when you put in one of the possible values. What it does with the while loop is it always checks your inputs before you try to use them. This is going to stop you from having some data issues later on. In this project, we're going to be modifying our assign volunteer 4 to use a while loop. So we're going to come over here and go to our assign volunteer 3, which is at least the closest we can come to it. And we are actually going to select all, copy, and paste into a assign volunteer 5. So new file, assign volunteer 5. Let that be a class, and let's paste all of that in there. Make sure that I don't have that at the top. Go to our main method, public class, and our import needs to go above. Okay. Couple of errors. Where else do we have an error? Oh, we've got an extra. There we go. And oh, it's probably upset because it's not in the class path, so I'm going to add chapter 6 to the class path. Okay. Then I can clean my workspace, and that should resolve all of those issues. Okay, so now we have our assign volunteer 5. After the input statement that gets the code from the user, but before the switch structure, so here's the input that gets this, but before the switch, so somewhere in here, we are going to be adding a loop. The loop's going to continue while the donation type is less than the lowest or higher than the highest, by asking the user, please pick from the choices that we have. We only have a couple of choices here, and we'd really like you to not pick 0 or 5 because those are choices that we don't know. So we're going to add ourselves a while loop. And our syntax is going to be while, and then a parenthesis, we're going to have our Boolean conditional expression. Donation type is less than clothing code, or, remember our 2 bars, donation type is greater than our other code. So in the situation where we have a 0 or less, or a 5 or more, we want to have the user re-enter their choice. And finally, we are going to ask them again to enter an integer and set the donation type to what they entered. So we will have 2 print lines, and then we will say enter an integer, and then they'll enter in. What this will do is it'll keep the user from being able to enter a number that we don't like. So let's go ahead and run us. Give ourselves a little bit. We're going to say 0, and it's going to get mad, and it's going to go, you entered 0, which is not a valid donation type. Enter a number between 1 and 4. Okay, fine, I'll pick 5. You entered 5, which is still not between 1 and 4. Enter another integer. Okay, I'll put in 10. Seriously, what's wrong with you? Why can't you pick the right number? Finally, I'll pick 3. It'll say, cool, thank you. You have electronics, and Lydia's going to take care of it. So you can see how the while loop will continue until it gets the value that it wants. In this situation, it wants a number between 1 and 4. One thing to keep an eye on when it comes to this is if we come down here to our donation types, we have this default option here. In theory, this should never happen, because if you didn't have a 1, 2, 3, or 4, then you shouldn't have been able to get out of the while loop, and you wouldn't have been able to get down this far. However, it's up to you if you choose to remove it. The default value, obviously, from the way we have it coded now, is not a possibility. But if we were to decide that there was another code in there, we might want to leave that in there, or something along those, just to verify it. So it's just up to you how you want to handle that. When we're working with mathematical numbers, programmers like to be lazy. We like to find ways of doing things so that we don't have to use up more code, use up more text any more than we have to. One of the things that we like is our shortcuts for arithmetic operators. So we can do an arithmetic operator and an assignment in a singular operator. We call these arithmetic operators. And they allow you to have a shortcut of adding to and then resetting the value of any of your values, any of your variables. You can do the math function and the assignment with a single operator. So normally you would say x equals x plus 4, but I can say x plus equals 4, and that will do both the addition of 4 to x and the assignment of that new value to x in one little operator. These are always really convenient just because they take up less space and they don't make you have to type the variable name over and over and over again. You can just do a plus equals to be able to add the value to the current value. You can do a minus equals, you can do a multiply equals, so on and so forth. The other part of this is what we call prefixes or postfixes, which is a plus plus in front of or behind a variable. And what it will do, there's also a minus minus, it either adds or subtracts exactly 1 to the current value. If my value is 10 and I do a plus plus, my value is now 11. If I do a value of 10 and I do a minus minus, my value is now 9. So the prefix and the postfix of plus plus and minus minus allow us to easily increment or decrement our variable. You can choose to put your prefix or postfix in front of or behind the variable name. So I can say value plus plus, and I can say plus plus value. By the way, C++ as a language, yeah, it comes from this. The difference is if you choose to do the plus plus beforehand or using the plus plus afterward, changes whether your assignment is equal to something. This is only difference is when it's used with an assignment. So if I make x equal to value plus plus, it gets the value before the increment. If I make x equal to plus plus value, it gets the value after. Let's look at some code to just verify this concept with prefix and postfix. On page 299, we're going to do a quick demo on prefix and postfix operators. So let's go ahead and add a new file to our chapter 6 called demo increment. Now, people are usually pretty personal about their incrementing, and they like to do their incrementing the way that they feel comfortable. In this case, we're going to be showing you prefixes and postfixes and kind of trying to show you the difference between the two. Sometimes it's a little hard to understand. So we'll start with our basic static void main. And inside of our main, we are going to make our integer v equal to 4. Then we're going to make an integer plus v equal to plus v. Finally, we're going to set our v equal to 4 again. And we're going to make another integer called v plus, which is going to be v plus plus. So we're essentially just going to be able to show you how these numbers change. Finally, we're going to do a couple of printouts. Now what you're going to see here is we set our initial value of v to 4. Plus v is going to be the value after v has been incremented. So plus v should be 5. In this case, v is back equal to be 4, and we have done v plus plus. In this case, it's going to set it to the value of v before the incremented, which means v plus plus is going to be 4. When we are finished with this line, v is going to increment up to 5. So in this case, when we hit our run, you will see that v got incremented here up to 5. That was fine. Plus v, this first one here, is the value after it's been incremented. and v++ is going to be the value before it is incremented. This is important to keep track of if you're going to be setting a value to the incremented value. If you want the value that you are setting it to be the incremented value after it's been incremented, you put the pluses on the left-hand side. If you want it to be the value before it's been incremented, you want it to be on the right-hand side. So now we're going to introduce our for loops. For loops are generally used when you have a specific number of iterations you want to run through. There are always 3 sections to a for loop. The first part initializes your control variable. So we're going to set our control variable to 0. We're going to set it equal to 1. We're going to create a new variable while we do this, or we're going to use a variable that already exists. But we're going to set our control variable. The second is a Boolean expression that's going to test your control variable. Is the value less than 11? I'm just going to check this over and over again until I find the answer that will break me out. So as long as this is true, keep going in my loop. And finally, we are going to use a piece of code to update our control variable, usually either a plus plus or a minus minus, something along that in this section. So you can have initializing your control variable, testing your control variable, and updating your control variable. In reality, in a for loop, any of these sections can be blank, but they still need to have the semicolons. So you can do a legitimate for loop with a for and 2 blanks and 2 semicolons in the parentheses, but it doesn't really make any sense. You really want to fill these in. It's possible that your control variable was already assigned before you got to the loop. Don't need to set the control variable, leave the first section blank. It's possible that you're updating the control variable inside the loop and you don't need to do it in your method header in your section up at the top. And that's okay too. So you could just put a semicolon and leave it blank. It's possible that you're doing a break or something on the inside so you don't need to test your loop, although if this was what you were doing, I'd really not recommend using a for loop. You really want to have your testing in there. For loops are always for a definite number of iterations. And you can figure it out if I had x equals 1 and I'm going to go x plus 1 each time, and I want to go until it's 10 or 11, then I'll know that I'm going to do it 10 times. We use curly braces to control the iteration block. What is the piece of code that's going to be run multiple times? So we use curly braces to hold that. There's a couple of different versions here of variations in your control area, so the declaration section. And they can just show you can have multiple variables in there. You can have multiple conditionals. You can use ands and ors. You can do minus minus. You can change something that isn't even part of your conditional, all inside of your declaration area. And that's okay as well. For this example, we're going to be working with definite loops. So we're going to be doing a loop that is going to go exactly X amount of times. Let's go ahead and add our new file, divide evenly. And in divide evenly, we're going to go ahead and add in our main function. All right. In our main function, we are going to give ourselves a constant or final integer that we say limit of 100. So we're going to say final int limit equals 100. It's our final variable. Then we're also going to have our regular variable that's also going to be an integer. We're going to print out what the number is evenly divisible by. So we're going to do a system out, and we're going to print the limit value, so that constant, plus is evenly divisible by, and then we're going to write our test case. In this case, we're actually going to do this as a print without the new line character. Okay, now we're going to go ahead and write the for loop that varies variable from 1 to 100. With each iteration of the loop, we're going to test whether or not it's divisible by 0. If you divide 100 by a number and there is no remainder, then we know that it goes in evenly. So we're going to write ourselves a for loop. For var equals 1, var is less than or equal to the limit, and var is going to increment. In this case, the book is going to have the plus var. I don't think in this case it's going to matter one direction. So if you choose to put the postfix or the prefix, either way is going to work just fine. Inside here, we are going to say if limit mod var. So we're going to take our 100 and divide it by our variable. And if that is equal to 0, which means there is no remainder, then I want to do my system out. And I'm going to do my variable and a space so that I can print out the list of all the things that 100 is evenly divisible by. Okay. Finally, at the end of my for loop, I'm going to go ahead and just do a regular system out just to print a new line so it will increment and it'll go to the next line finally at the end. Okay, so at this point, I can go ahead and run it. I have no squiggly lines. It looks good. What it should do is run through this list. I did a print ln. Let me make that print ln print. And it'll do a list of all of the numbers between 1 and 100 that 100 is evenly divisible by. So what it did was it started at 1, and it said, is 100 divided by 1 0? Yes. Cool. Let's go up to 2. Is 100 divided by 2 evenly divisible? Yes. What about 3? Nope. What about 4? Yes, because you can get 25. What about 5? Sure, that's 20. What about 6? Nope. 7, 8, 9, 10. 10 goes through. 11, 12, 13, 14, so on and so forth, until it got up to 100. This is a nice, easy, quick way to be able to get all of the factors of a given number. So we've already introduced you to a while loop. So understanding a do-while loop should be relatively easy. The difference between a do-while loop and a while loop: a do-while loop does not check the test condition until the end. While loops check the test condition at the beginning. So if you have a piece of code that you want to make sure runs a single first time before it has the option to loop, it has to run the first time. You can do a do while loop. Start with the word do, curly braces, and then at the end of the curly braces, throw in your while clause. While response equals 1. In this case, you don't have to have the code that says enter 1 for yes and then asking the input. You don't have to have it twice, because if you were doing a regular while loop, you would put it at the top before the while loop, and then of course put it at the bottom of the while loop to find out whether the user wants to get out. With a do while, we know we want to run the code the first time. So you can use a do while, run it the first time, and then give the user the option of breaking out at the end rather than the beginning. This is useful if you want to run your code before you do your check. Here's a section of code that you can go run and do yourself. It's not in the book. It was in a previous version, but it does give you the option of doing a while loop with a sentinel. So in this case, we are going to have the user enter a number. We're going to make sure that that number is not 0. And then we're going to say you entered this number, enter either another number or 0 to quit. As long as that X is not 0, you should be able to continue doing this a few times. It's just a couple of lines of code, and it might be really easy for you to see, once you've written the code, how this while loop concept works. So just like we said with if statements, you can nest your loops. You can have loops inside of loops. The inner loop must be completely contained. You have to have the whole loop inside of the outside loop. So you could have the outside loop, testing that, go in, test the inner loop, run the inner loop multiple times until it falls out of its loop. Then it goes back and increments or moves along with your outside loop. It's actually really useful if you wanted to display like 2 dimensions, kind of like a matrix, being able to print things out. It's useful for things that have multiple values that you want to be able to print multiple times. Make sure when you do a nested loop that you have different control variables, because if you have the same control variable, when you iterate through the inner loop, you'll be modifying the control variable for the outer loop as well. So it's important to make sure you have completely different control variables. Some people use I, J, K, some people use A, B, C, depends on what your situation is for your specific loop. But you can do nested loops, and they are actually very, very useful. At this point, we're going to take our divide evenly, and we're going to make divide evenly 2. And in this case, we are going to just copy and paste. There it is. And this version of divide evenly, we are going to name divide evenly 2 so that it can be in the same spot. Let's rename it here. And we're going to change this into a nested loop. So I'm going to grab it, drop it in there. Yes, I am sure I want to move that. And we've got our divide evenly 2. Cool. At this point, I want to go ahead and instead of having just one number, the number 100, I want to actually do a bunch of numbers, find out every number from 1 to 100 and what are its possible factors. So I'm going to replace my existing loop with a nested loop. We're actually going to keep a lot of the code and just kind of tab it in. So first I'm going to do for number equals 1, number is less than or equal to limit, number plus plus, and my open curly brace. I'm going to then tab in all of those. I'm going to go ahead and make this a new variable here that is an integer, so I can use that. Okay, so what I've done now is I have said, okay, so for number is 1 up to 100, and I want to change what is that number here instead of being limit, and I'm going to change a few of these to also be number, because I only really need to go up to number. I don't need to go up to 100 if my number is lower. So in this case, what this says is for all of the numbers between 1 and 100, in this case, that's my limit, print out the number is evenly divisible by, and then we're going to print out the list of its possible factors, starting from 1, going up to the number. So if I have the number of 4, it'll go 1, 2, 3, 4. There's no reason to go over it because that would get you 100%. That gets you the full number. If the number mod variable is 0, we know it's evenly divisible, and we can go ahead and print it and add the space, and then at the end of each of those, it'll print a new line. So now I can clear that out, and you'll see it's going to run through every number between 1 and 100 and give you all of the factors of that number, all the possible factors. Isn't that nice to be able to do that without having to do all the math? Again, this is why I love computers. They allow you to do the calculation part of math, the stuff that you know how to do, it's just tedious, by doing it all quickly. Couple of comments on performance. There's actually a really good You Do It on performance that you might want to go through and do yourself that just shows you how things are different depending on your situation. Doing 2 things inside of a loop instead of doing 1. Making sure the loop doesn't perform unnecessary operations. Couple of things that we like to do with loops. First off, if you're going to do a static value, say a plus b, calculate it first and then use it inside of your loop with a third variable. Don't ask it to do a plus b every time. It's unnecessary to waste that time. If you're going to be getting a value from a method, get the value from the method early as a variable and then compare it to the variable. Don't ask it to run the method every time because that makes unnecessary operations. If you can choose to make your comparisons to 0, that's easier. The computer likes the word 0, the number 0. It likes comparing things to 0. It prefers 0 to x plus 3. If y is less than x plus 3, that's harder for it to do than if x minus 3 equals 0, or however you want to have it work. Point is, if you make a comparison to 0 instead of making a comparison to some mathematical operation, that helps. You want to use a postfix over a prefix if given the option. As the example is here, we ran the same piece of code multiple times. How long did it take the code if we were doing prefixes versus postfixes? And you can see the difference in time. So postfixes are generally more efficient. That doesn't mean that there's anything wrong in your code by using a prefix if that's what you want to use. Just be aware. When programming first came out, when people started really programming in languages like C and C++ in the 90s, memory was very, very important. Space was very important, and we had to take into account performance issues. These days, memory's pretty cheap, and you probably are not going to be taxing the limits of your memory. However, it's always good to recognize these performance issues when you're coding and trying to make your code as efficient as possible. Okay, couple of things to remember with Java and looping. You do not put a semicolon at the end of the while clause. So you don't do while semicolon. You put in your curly braces and you move on. If you're going to put in multiple statements, make sure you block them. Same with if statements. If it's a single statement, you don't have to block it with curly braces. I do anyway. Data validation tends to use a loop instead of an if. The reason why is because people make lots of mistakes. If I give you, you have to choose a number between 1 and 10 and you pick 43, do I really think you're going to get it right the next time? Should I just do an if, check it once and move on, or should I do it as a while loop until you get it right? Make sure you check your comparisons with your greater than, less than, equal to. Make sure you understand how those are done. And try not to repeat steps inside your loop that could have been done outside. Remember, if I'm running this loop 100 times, I'm going to run every line of those code 100 times. If I'm doing a mathematical operation, or if I'm doing a step that could have been done outside of my loop, I don't have to run that statement 100 times. I only have to run it once. Again, efficiency, always good to keep an eye on that. Thank you so much for watching this lesson on looping in Java. Please come back next time for Chapter 7. Have a great week.